Have you ever wondered what lies beneath the vast oceans? There is a world teeming with life, shaped by geological forces just as powerful as those on land. This underwater world is home to seamounts, mountains that rise from the ocean floor but don't break the surface. Formed by volcanic activity, these submerged peaks become hotspots for marine life, creating a rich tapestry of biodiversity. Much like their counterparts on terra firma, these underwater mountains can be active volcanoes spewing molten rock and reshaping the ocean floor, or they could be dormant, sleeping giants waiting for their time to come. And some are extinct, their fiery hearts long since cooled. But regardless of their state, they play a crucial role in the marine ecosystem. So seamounts are not just underwater mountains, they are vibrant ecosystems, geological wonders, and potential treasure troves of resources. But how do these underwater mountains form? The answer lies in the dynamic nature of our planet. The formation of seamounts is a fascinating process, deeply intertwined with the movements of the Earth's tectonic plates. Picture two colossal slabs of the Earth's crust drifting apart in the middle of the ocean. This is what we call a mid-ocean ridge. As these plates separate, they create a gap, a void in the Earth's crust. This void provides an escape route for the molten rock, or magma, from deep within the Earth's mantle. As the magma rises through the gap, it cools and solidifies upon contact with the cold ocean water, creating new sections of the ocean floor. Over time, this process repeats, building up layer upon layer of solidified magma. Eventually, these layers form an underwater mountain, or as we now know them, seamounts. The planet's two most studied mid-ocean ridges are the Mid-Atlantic Ridge and the East Pacific Rise. These ridges serve as the birthplaces for countless seamounts, each one a testament to the unceasing dynamism of our planet's geology. But mid-ocean ridges are not the only places where seamounts can form. Some seamounts have also been found near intraplate hotspots, regions of heavy volcanic activity within a tectonic plate. These hotspots are like underground volcanoes, spewing magma that forms seamounts much like those at mid-ocean ridges. Oceanic island chains with volcanic and seismic activity, known as island arcs, are another location where seamounts can form. The intense volcanic activity in these areas produces vast amounts of magma, which rises to the ocean floor and forms seamounts. So seamounts are not just isolated underwater mountains, they are strategically located features marking areas of high volcanic and seismic activity on our planet. Every seamount has a story to tell, a story of fiery eruptions, of shifting tectonic plates, and of the incredible forces that shape our world. Thus, seamounts are not randomly scattered underwater mountains, but are strategically located in areas with high volcanic and seismic activity. You may ask, why should we care about these underwater mountains? Well, seamounts hold significant importance in several ways. Let's start with their geological significance. Seamounts are like windows into the Earth's mantle, the layer beneath the crust. They provide invaluable information about the mantle's composition. This, in turn, aids scientists in understanding how tectonic plates evolve over time. When the Earth's plates move and molten rock rises to the seafloor, seamounts are formed. By studying these formations, we learn about the mechanisms of plate tectonics and the Earth's interior. But there's more. Seamounts also have a profound impact on the circulation of water in the oceans. They act as obstacles to ocean currents, causing water to swirl around them. This process can result in the mixing of warm surface water with colder, deeper water, influencing the distribution of heat and carbon dioxide in the oceans. Hence, seamounts play a pivotal role in the global climate system. Now, let's dive into the biological significance of seamounts. These underwater mountains are hotspots for marine life. They cause localized ocean upwelling, a process where nutrient-rich water from deep within the ocean moves up to the surface. This nutrient-rich water fuels the growth of phytoplankton, the base of the ocean food chain. As a result, seamounts become oases of life in the deep sea, hosting a diverse range of species from tiny plankton to gigantic whales. In addition to supporting a diverse array of marine life, seamounts also serve as stepping stones for species migration across vast oceanic expanses. They provide critical habitats, feeding grounds, and breeding areas for various species, including many that are commercially important for fisheries. In essence, seamounts play a crucial role in our understanding of the Earth's geological and biological processes. They are not just underwater mountains, they are dynamic systems that contribute to the Earth's health in ways we are only beginning to understand. Now, let's take a trip to the central Indian Basin, about 3,000 kilometers away from India's coast, and explore the Afanasy Nikitin Seamount. The Afanasy Nikitin Seamount, named after the Russian merchant and explorer Afanasy Nikitin, is an underwater marvel in the central Indian Basin. This seamount is a structural marvel, a colossal hill that towers 1,200 meters above the surrounding ocean floor, which rests at a depth of 4,800 meters. Imagine a mountain rising from the ocean depths, a silent and majestic giant, silently observing the world above from its dark and mysterious depths. The Afanasy Nikitin Seamount is just such a giant, a submerged mountain nestled in the heart of the ocean. But this isn't just any mountain. The Afanasy Nikitin Seamount is a treasure trove of valuable resources. It's rich in deposits of cobalt, nickel, manganese, and copper. These minerals, essential for various industries, are nestled within the seamount, waiting to be discovered and utilized. Cobalt and nickel are vital in the production of rechargeable batteries, a key component in our journey towards sustainable energy. Manganese is used in the production of steel, an indispensable material in construction and manufacturing. Copper, on the other hand, is a versatile metal, used in a wide array of applications from electronics to plumbing. These deposits make the Afanasy Nikitin Seamount more than just an underwater mountain. It's a potential source of valuable resources, a reminder of the untapped wealth that lies beneath the ocean's surface. But the Afanasy Nikitin Seamount isn't just about the minerals. It's also an important landmark for our understanding of the ocean floor and its geological processes. It's a living testament to the Earth's tectonic activity, a physical manifestation of the incredible forces that shape our world. The Afanasy Nikitin Seamount is just one example of the intriguing and resource-rich underwater mountains that lie beneath our ocean's surface, waiting to be explored and understood.